Shine a flashlight into the sky at night. Turn off the flashlight. Where did this light end up? Will it reach the edge of the universe? First turn off the flashlight, but the beam of light disappears. The light that has been emitted will not disappear. Light is energy. The essence of light is the quantum of light. Well, energy doesn't just disappear. So once the light goes out, there can only be three outcomes. The first, of course, is that it is absorbed by other substances. The second is to fly in space all the time. Of course, there is a remote possibility. Falling into a black hole. And of course, most of the time, light is absorbed, because the flashlight first passes through the atmosphere. There are too many air molecules in the atmosphere. As these photons pass through air molecules, extranuclear electron generation in gas molecules, that is, it is absorbed by extranuclear electrons. The energy of the electron increases after absorbing the photon. Leap lead occurs. Then release the photon again. But this time the photon path released again. It may be different from the original photon path. That's why. The reason why light reflects slowly in air. If the light is not reflected slowly in the air, then the naked eye is not looking directly. It would be impossible for us to see these lights. After light passes through the atmosphere, then it will enter the inner space. Actually, there are microscopic particles of dust in interstellar space. Light may also be absorbed by this dust. But then the probability is very low. After all, the density of matter in interstellar space is very low. Then these rays of light may arrive on a certain planet, absorbed by extra electrons on the surface of this planet. You see, light, whether absorbed by air molecules, still palpitated by dust, or other Socke absorption, its essence is photons and the interaction of atoms with external electrons. This is what Einstein did in 1905, the proposed photoelectric effect. The light from the flashlight, in addition to the photoelectric effect with electrons, there's also a theoretical possibility. Absorbed by the black hole. Once absorbed by the black hole, then the light is completely gone. But this possibility is only theoretical, hardly exist in reality. Whether absorbed by a black hole, or is it absorbed by other lines, this probability is very low. After all, the universe is so empty. So how empty is the universe? Take, for example, the densest region in the center of the Milky Way, galactic center. Stellar density per cubic light year, just 2 stars. That's about the size of the Earth. Put 500 footballs, and the density of matter in space outside the galaxy is even lower. It's about the size of the Earth. Only 1 football was played, and that's just inside galaxies. Galaxies and galaxies, the density of matter between them is ridiculously low, so light travels through space. The probability of being absorbed by celestial bodies is very low. In fact, the light emitted by the flashlight, except most of it is absorbed by air molecules, the rest of the light almost always travels through the universe. Can these rays reach the edge of the universe? From the current astronomical perspective, these rays of light is unreachable at the edge of the observable universe. But it will reach the future, the edge of the universe where causality occurs. What does that mean? And here you see what we now call the universe. Refers to being centered on the Earth. a sphere with a radius 46.50 billion light-years. This space is also called the observable universe. This radius is also called the particle world. The particle world refers to the birth of light in the universe. After 13.80 billion years of flying, plus the expansion of the universe, the area reached, we can still see 46.50 billion light-years away, just because of these lights used to be very close to us. In fact, according to the latest observations from the Planck satellite, galaxies are about 3.6 million light-years from Earth. Its regression speed will increase by 67.8 kilometers per second. Estimate. Approximately at a distance from Earth, 14.30 billion light-years away. Space is expanding faster than the speed of light. So light 14.30 billion light-years away can't reach Earth. Then cosmic events beyond this. There would be no causal relationship with the universe. We can't see them. Of course, in the future, we can see the observable. Cosmic scope will increase. This is because of early cosmic light. Not enough time to reach Earth. After these rays reach the Earth, our observable universe will get bigger. And the universe is accelerating its expansion. That is to say, we're going to see a bigger universe in the future. But the region that is causally related to the universe will only get smaller. The observable universe gets bigger, just more and more. There is enough time for the light to reach the Earth. Causal universe shrinks because the universe is expanding faster and faster. The speed of light and space expansion, regions of space with equal speed, will continue to contract in the direction of the Earth. So now the light emitted by the flashlight will not reach the edge of the observable universe, but it will arrive, the edge of the universe where causality will occur in the future. But be careful, the reasoning in the video are based on existing astronomical models. The accelerating expansion of the universe was only discovered in 1998. Maybe new phenomena will be discovered in the future. It may be correct for this theory. By then, will these rays reach the edge of the universe? It's hard to say.